This is my chapter number 9, algorithm design and problem solving. And when we talk about this, main thing that we need to know apart from algorithm is my computational thinking, in which the very first term is abstraction. And in this, you can see essential part of computational thinking enables computer scientists to develop clear models for the selection of complex problems. This is going to be involving extracting information that is essential while ignoring what is not relevant. Now, this one is abstraction. You will pick up all the required stuff and you will ignore what is not required. Like this is the diagram of reaching from one point to another. So if I give you the example, I want to go from here to generations or any other place. So what will I do is I will only look at the map leading to generations or any other place, and will ignore all the other parts. That is what is abstraction. So you can see here, then it is going to make your work a little simpler, because that will be dealing with only working on what is required, and whatever is not required will be eliminated, will be ignored. But I will not pay attention to whatever is not needed. So that is what is called abstraction. Like again, one more example. Although I have the whole book with me, you can see it shows AS and A levels. But right now, my concentration is only on AS level. I'm not even referring to anything from A levels at all. But that is not my requirement at all. So that is called abstraction. Yes. Clear? Kuch samajh aayi? Hmm?
Yes.
The benefits of eliminating any unnecessary characteristics. That is what you need to know as well. The time required to develop the program is reduced, so the program can be delivered to the customer quickly. Like when you are concentrating on the main thing only, then you will not be referring to other stuff, and that is what is going to benefit you. The program is smaller in size, so takes up lesser space in the memory, and download times is also shorter. Customer satisfaction is greater as the requirements are met without any extra, without any other features not at all needed, will be ignored completely. Are you clear with this abstraction? Can you recall this example of moving on from my home to generation? So I'll be getting the whole stuff, but I'll ignore all the stuff. I will only concentrate on the path that is leading from my home to generations. So that is called abstraction, ignoring what is not needed and only concentrated on the basic thing. Yes, clear? Are you clear with this? The first
Yeah.
abstraction is what we do here is, you can see the first stage of abstraction is identify the purpose of the model of the situation that is to be built. That you need to know why are you creating it. First of all, you need to identify. Like I talked about you. I'm like, for example, last year some students were with me who had taken exemption. So exemption means that I didn't concentrate at all with the P2 with them. For me, their P2 was, although I taught them, but they neither they or I was concentrating. So that's what that was again abstraction. So this is something that we keep on doing the whole time, all the day. We concentrate on the main thing and ignore what is not needed. That is called abstraction. Ji, clear, beta?
Yes.
Moving on to the next thing that we need to know is called decomposition. By the way, if you look at this diagram, this is something that we have learned even in O levels. That means that you are going to divide the main task into subtasks, and that is going to make your life a little easier, because you are going to break the complex problem into smaller parts, and that can be more manageable. Like it is easier to manage a task that is further subdivided. That is what is the idea behind decomposition. As the name implies, dividing the main task into subtasks, the way we say the animals or the different parts, plants or the other stuff, they decompose. They are, I can say, they are divided into different small pieces. So same goes, same thing goes here. We are performing decomposition by applying a rule that whatever bigger task is there divided into smaller tasks, that everyone can manage it easily. It will not be done by one person only, it will be managed by different people as well. That's what that is also an advantage. You can see until each part is easy to examine and understand, and a solution can be developed for it. When a rigorous decomposition is undertaken, many simple problems are found to be more complex than at first sight. Now, this is why when we are decomposing, what is the advantage is that rather than talking about one thing, we can divide it into multiple small problems. And when you look at that problem, what is the advantage is people can handle it easily. They may know कि जी क्या मसला है. They can concentrate more on this one, and that is what is the advantage of decomposition. By the way, what is pattern recognition? If you pay attention to this, it's used to identify those parts that are similar and be used could use the same solution. Like the thing that I'll be talking about right now will be procedures and functions. And then you can see if I am working on a small task and that task has something that will be needed in many places. So rather than making the program repeatedly, what I can do is I can make a procedure, I can make a function, and that will be called whenever I want to. That is what is the idea behind pattern recognition. Whatever is there, don't redo it. Just reuse that is already there. That is what is the idea behind this pattern recognition. As you can see, this leads to development of a reusable program code in the form of subroutines, procedures, and functions. Like rather than keep on writing it repeatedly, making your code a little longer, what we can do is we can put it in subroutine, we can put it in function, and we can have it called whenever we want to. When writing a computer program, each final part is defined as a separate program model that can be written and tested as a separate procedure or function. Now, although we are okay, now this is also called modular approach. Now these terms will be used later. So once they are being used, so you need to know whenever we talk about decomposition, what do I mean? Or what do I mean by modular approach? The same thing. As you can see, one program is divided into two modules, which are further classified into submodules, which are further classified into submodules. So you can see this is how we can see this is called pattern recognition. Whatever is available and required at many places, don't keep on reusing it. Just keep it once and call it whenever you want to, wherever you want to. Are you clear?
Yes.
Now, be very much concerned with these two terms because they can come in the paper. Like there is a very high probability of us getting the question. By the way, structured English, pseudocode, flowcharts, simple programs that we have talked about, and you can see the same input statement, output statement, the way we have talked about in O levels. Same case goes here. Case of otherwise and case if, and then the user operators. I hope that we are clear with these operators. And then, okay, now as far as this is concerned, that will be considered inshallah in A2, not this year, because our concentration is only towards AS. In AS, we will concentrate mainly on pseudocode writing, not on programming at all. So जो जरूरत नहीं है उसकी तो हम उस पे उसको concentrate ही नहीं करेंगे. Now you can see any questions regarding repeat until, for, or while do and while. I
No.
did a presentation of that as well, so you can refer to that as well if you want to. Now moving further, uh, any questions? If you have any, then please do interrupt me. Otherwise, I'm just showing you that what can come in my paper. I may be given a question that contains structured English, and I may be asked to convert that structured English into a pseudocode or maybe flowchart. So you need to be well versed with how to convert that as well. Very simple, just a little bit of the practice, and then you will be able to manage. Now, a lot of activities we have done earlier. Again, you can see stepwise refinement.